muted today just because of feedback and everything else. But if you have questions, type the questions, and then Amy and I can read them, and either if they're simple questions, Amy will respond in writing, or else I can respond just on the webinar. So again, if you have any questions, feel free to go ahead and chime in and type your questions in the chat bar, and we will answer those. But I'm going to go ahead and get started now, and I'm going to zoom into the first pond that I'm going to do, and it's in Carroll County. And so all of our software is software as a service. It's all online tools, so you just go into the web browser, you pull up the URL, you log in. We license our software on a yearly basis, and so if you have a login, you just log into it and you get access to it. We now have our tools operating in about 8 states now, all in the upper Midwest, Illinois, Indiana, Minnesota, Nebraska, Iowa, some in Wisconsin. So as we're collecting the LiDAR data, we are ramping up for those states. All right. So with that being said, this is the interface for PondBuilder, and you can either get to your location by just zooming to the location and panning where you want to go like any other GIS program, or you can type in your Google address, you can put in your township range and section, or a latitude and longitude. Just because of the history of how I've worked with things, I usually use the section, township, and range, and so I'm going to plug in the location to my first pond that I'm going to work on. As I said, it's in Carroll County. And I just pulled these sites out this morning as sites to go to and use. Okay, so once I get to the location, this is just on the east side of Coon Rapids, Iowa. I'm going to turn on my imagery, and then I will also go down to my layers, and I'll turn on the contour layers. And you'll see 2-foot contour layers pop up here. And these 2-foot contour layers were developed by the LiDAR data, but they're not used to actually design the pond. We're actually going back to the original digital elevation model to do all the design work, but the contours are here for us to use as drawing in dams and drawing in watersheds. So I'm going to simply start by drawing in my watershed, and I'm going to start at the top of one hill where I want my dam to start, and I'm going to go to the top of the other hill on the other side down through the draw. And so where the red line is, that is where my proposed dam is. The next thing I'm going to do is I'm going to draw in my watershed. And so this is a pretty easy task once you understand contour lines. But I'm just going to go ahead and I'll draw in my watershed. I won't be perfect, but it will definitely be good enough for the purpose of today. Okay, when I get to my other end of my dam, I double click, and that closes my loop for my watershed, and it tells me that my watershed is 133 acres for this pond. The next step I'm going to do is I'm going to draw in my longest flow line. So this gives me time of concentration. So it tells me, is my watershed kind of round, and is all the water, when there's runoff, is it hitting the dam at one time, or is it kind of a long, narrow watershed where the water is hitting the dam at different times as it runs down the watershed. So at this point in time, I'm going to just simply draw in what I believe is my longest flow line, or the longest distance that water is running from the top of the watershed down. As I talk to engineers, this is not a critical step, but we want to get pretty close to what is the longest flow line. So I double click, and it attaches to the upper end of the watershed and goes all the way down through the dam in the flow path that I perceive as the longest flow line. If I want to adjust those points, I can click on the edit button for draw flow lines, and I can move this flow line around if I would like to, but I'm going to keep it where it's at. Then I'm going to do a runoff curve number, and I can either estimate the runoff curve number if I am a technician that's worked in a county for many years and I'm pretty good at estimating the runoff curve number. I can simply click on yes and put in whatever runoff curve number I want, but if I don't know what it is, I'm going to start the process of calculating a runoff curve number. So again, if anybody joined late, I'm just in the process of designing a pond. And if you have any questions about the process, please type those into the chat, and Amy and the Agrin staff will answer the questions she can, and then the rest of them will leave till I'm done here. So right now, as I calculate the runoff curve number, what it's showing me is that a good part of my soils are already categorized in one category, but there are some soils that need to be categorized in the A, B, C, D hydrologic group. And so I know what it calls for is that if I know that these areas are tiled, which I do, I would use the lower letter in the alphabet, so C, and if they're untiled, I would use D. But I'm going to go ahead and apply the C to it, and you can see now that I have my hydrologic groups of A, B, C, and D throughout my watershed. My next step, my second step in create a runoff curve number is then looking at the land use, because the runoff curve number is made up of two values. One is first is the hydrologic soil groups, A through D, depending on how much sand, silt, and clay is in the soil, what permeability of the soil is, so we know how much water, when it rains, how much water is going to run off and how much water is going to infiltrate. And so the runoff obviously needs to be stored by the pond. But the second part of the runoff curve number is really the land use and what's on top, going on top of the ground. And for this, I'm going to turn off my contour line layer, so I just have my aerial view, and I am going to cut up my polygon, or cut up my watershed into different polygons. So I'm going to cut out the road first off. And this is a pretty simple runoff curve number to do. The land use is pretty simple here. And then I've got a bit of a farmstead that sticks over. So I've got cropland, I've got a road, and I've got a farmstead. So once I have those polygons cut up, then I'm going to go through and I'm going to label those. And so I'm going to go row crop, crop residue good. And this takes a little bit of training. It's not an automatic thing that you know exactly what to do. But once you know how to do them, you can do them in just a few minutes. So I'm now going to move down. I'm going to assign this in my list of farmsteads. And then lastly, I'm going to go down and I'm going to use a gravel road because that's a gravel road. So I've assigned my A, B, C, and D hydrologic soil groups. I've assigned my land use. And now I'm going to calculate my runoff curve number. And so it's a runoff curve number of 77. I'm going to apply that. And then the next thing I'm going to do is start generating pond options. And so I clicked on the generate pond, and it starts a wizard where in just a few seconds it will pop up some default values for me. We've tried to use the default values of the Natural Resources Conservation Service, of their standards and specifications, but you're allowed to override those if you want. And so in a couple seconds, we'll get a couple dialog boxes where we can review the default values. So it plugs in a runoff curve number 77. Again, if I want to override that, I can. Gives me an average watershed slope of 9%. If I want to override that, I can. The top width will be determined. If I want to plug in a minimum top width of 14 or 12 feet, I can do that. But I'm just going to take what standards and specifications tell me. Front slope 3:1, back slope 3:1, settlement 5%. And so you can see all the different variables here that you're allowed to either accept as default values or you're allowed to change if you want to change those to something else. I'm going to go ahead and accept those default values. And then it asks me what kind of pipe I want to install. And I can check multiple types of pipes. If I want the annular corrugated metal pipe, I can click that. If I want PVC, I can click that. And then I have to specify how wide I want my auxiliary spillway, 10 or 20 foot wide. and then I'm going to simply click on Finish. I'm just going to accept 10-foot wide spillways for this design. I'm going to click on Finish, and now it's going to start generating all the possible pond designs for the options that I requested. So I'm going to have multiple pipe sizes. I'm going to have 2 pipe types, the PVC and the annular corrugated metal pipe. And then I'm also going to have the options for a 10-foot wide auxiliary spillway. And so the program is going through and generating all these options. It looks like there's initially 300 and some options. Some of them will be thrown out just because they're just not going to meet standards and specifications. But it's going through and generating, figuring out which ones are good and which ones are bad of those 308 options, and then it will display those for me. And so here's my table of options that are available to me. I can sort however I want. I can sort by cost. So the lowest cost dam I'd build here is about $5,200. The highest cost one is $13,790. Now associated with that are different pool depths, the maximum pool depth, the pool size, the settled fill, the drainage to surface area it's given, different pipe sites and different pipe types. So this is a 4-inch pipe that I'm given for PVC, and so you can go through and you can sort out what you want. What I know about pond design in Iowa is we like a ratio here of about 15 to 20 to 1. So if I kind of scroll down here and find something in that ratio of drainage area to pool size of about 15 or 20 to 1, I can use this 17 to 1. And so when I click on that 17 to 1, I see that I'm going to have an 8-inch PVC pipe. And so I can look down through all the options I want. I can look at a 12-inch pipe, a 15-inch pipe, 18, and based on average cost of earth fill and pipe, it gives me the associated cost of that dam. So once I decide on which one I want, I'm going to display it on the map. And so what it's doing now is it's calculating the surface area of the pond for me, and it's going to display it on the map. And so this will be about a 7.8 acre surface area pond under natural conditions with no excavation, because we don't know where the contractor will get the dirt from. You know, we assume it's from the pool area, but since we don't know, we're just giving the pool depth as if they hauled in the dirt and they didn't do any excavation from the pool area. So the maximum depth there is 11.5 feet. The dam fill height at center line will be about 16 feet. From the back toe, it's about 17.5 feet. So you can go on down and you can see all the different displays that we have here. And so if this is the pond that I want, because I can go through and I can select any pond and I can view it. But if this is the pond I want, I'm going to go ahead and I'm going to create a report. And there are, again, some more default values. If I want to accept the default values as they are, like I'm going to put in a berm that has a top width of 8 feet, and the berm's going to have a 3 to 1 side slope. I can put in nothing if I don't want a berm. I can zero these out. Then it gets to the core trench or the foundational cutoff. Again, it gives some default values that you can use, change, or zero out. And then there are the costs associated with the berm fill, the foundation cutoff, and excavation. I'm just going to go ahead and accept those how they are. Click Next. Has some information that I can go ahead and fill in if I want to, but there's no reason for this purpose to go fill that in. But you can put in the client name and the prepare and different things like that. And now it's creating my PDF report. And so it's generating a report for me that gives me all the information that I have for this pond. So I selected this particular row right here, and I'm developing a report, a design for that particular row. So it's for an 8-inch PVC pipe that's, like I said, 7.8 acres surface area, and under natural conditions or original conditions about 8.5 feet wide. And so it's packaging all the information up into this PDF, and it is creating a file for me. When I click on open, then it will open the PDF for me. It will give me a picture of what my pond's going to look like. It will give me the estimated cost, a disclaimer that this is not an engineering design, and we do not pretend it is. Regardless of what software you use, anytime that it's an engineering design, a professional engineer has signed off on it. They've put their PE stamp on it, and it is not an engineering design regardless of the software that you use until PE puts their stamp on it. So we do not represent this as an engineering design. We represent it as a plan that an engineer can look over, and if they approve of the methods and where it's at and everything, like any other software program, they put their professional engineering stamp on it. There's a cross-section of the dam, and so we've got the information for the top width, which for this case it's 10 feet. We have the constructed fill height, and so you can see on and on down all the information that you get in elevations and everything else. I don't think I said this from the start, but all of our designs are based off of the publicly available LiDAR data. So in Iowa, Minnesota, Illinois, Indiana, Nebraska, we went and we've collected all the publicly available LiDAR, and that's what we're generating results on. And so if you're not comfortable with the LiDAR data for generating design results, then you can use this for a planning tool. If there are a lot of engineers that have been using the LiDAR data and putting their PE on it, that's the choice of the engineer and putting their PE on it. Okay. Then there's all of the planning details. There's the drainage areas given, the average watershed slope, runoff curve number, dam height, the volume of the permanent pool, temporary pool. I mean, just all the information that you would want for designing on a pond. There is the stage storage graph, and so if you want to develop or look at your stage storage information, you can do that. And then there's the earthwork equations, and so similar to any other pond construction, we develop the equations for developing the earthwork dimensions. This is what I would call kind of case file information of the runoff curve number, how we got to this. This is the worksheet for the runoff curve number. And finally, these are all the technical calculations. And so if you want to run through those technical calculations, they're all populated with the information from the pond that we gathered. Okay, so that's pond number one. Took 20 minutes with all the explanations involved, and so pretty fast. And so we'll go through them a little faster unless you have any questions. Amy, are there any questions that need to be answered?
I just answered one in chat for what the base cost includes.
Okay.
But everybody saw the answer to that. So.
All right. So Amy said that somebody asked the base cost, and that's involved in the actual yardage of the dam and the pipe. And then the other things are added in after that. Okay, so I'm going to move on to pond number 2. And again, I am going to go to another site in Iowa. And I need to erase that pond because I only can do one pond on a screen at a time. So I need to erase that old one. And then, let's see, let's zoom into a location. And let's choose a site here. All right. I think maybe I'm going to turn on my contour lines. And this looks like a nice location for a pond right across here. There's nothing special about it, but it certainly serves as a good pond site. And so I'm going to start again at the top of the hill or near the top of the hill. I'm going to go across to the other side, go down through the draw across to the other side. I'm going to double click. It's going to put my pond in where it needs to be. Then I'm going to go ahead and I'm going to draw in my watershed. All right, got my watershed drawn in. Then I'm going to do my longest flow line. Again, this is to calculate the time of concentration, and this is kind of my perceived longest distance that water is going to run. And so again, anything is editable. If you don't hit the right spot the first time, go ahead and edit those. The runoff curve number, again, I'm going to say no, I don't know what it is. And so it's going to start pulling up the soils here for the A, B, C, and D hydrologic group. It's going to classify those ones that only have one group. It's going to show those that have a choice. It's going to show them, and I need to make that choice of those hydrologic soil groups. And so we'll see here in a second what results it's giving us. All right, so almost the entire watershed is delineated here as C, but there are a couple spots that I need to make a choice on. I'm going to call these spots both C, and I'm going to apply it to the whole watershed. It becomes C. I'm going to go ahead and turn off my contour lines because I don't need those anymore. And now the next thing I'm going to do is my land use. And this land use is a little more difficult, and I won't take the time to do a perfect job. But we'll make some polygons here of different land uses, and but again, you will want to be as careful as you feel you need to be while you're doing this on your own. I would call this maybe a farmstead. And you might want to split out the pasture from the woodland, but I'm going to call it all pasture land for this polygon here. Let me zoom in a little bit so maybe it's a little more clear on your end. So I've got polygons for the pasture land. I've got some cropland here. I've got cropland here, and I've got a farmstead. And so now I'm going to go ahead and I'm going to assign those polygons, and I can do this first one as kind of brush, or I can do, let's see, maybe we want to do pasture meadow there in good shape. I'm going to move to the farmstead one, and I will assign that farmstead. And then I've got my two left for the row crop, and I'll do contoured, no terraces because I don't see any terraces there. And then this last one I'm going to do as, I'll do contour crop residue good too there. So I've assigned my entire watershed at this point in time. I'm going to calculate my runoff curve number. It's 78. And then I'm going to start through my wizard where I'm going to pull up all the possible parameters, and I'll check the default values on those and see if they're what we want to use or if we want to make any modifications. So as I go down through this, maybe one of the things I want to do is instead of a 3-to-1 front slope and back slope, I might want to flatten those out to 4-to-1 just to show you how I can do this. So I'm going to override the values there, and you can see as I override them in the right-hand column, the left-hand column shades out. That the left-hand column is the recommendation by NRCS standards, but the right side is what I've chosen to override. So now I'm going to go ahead and click on Next. This time I'm just going to do smooth steel pipe as an option, and I'll continue to do the 10-foot wide auxiliary spillway. So I'm going to click on that, and it's going to start running all the options for me for my different options of ponds. And so this takes about a minute to run generally, but it will give me all my options for my smooth steel pipe, all the options in half-foot increments of water depth from a minimum to a maximum, and it will show me all the information that's associated with that. Oh, it also gives me all the different sizes of pipe from a 4-inch to a 36-inch pipe. So you have the 4, the 6, the 8, the 10, the 12, 15, 18, 21, 24, 30, and 36-inch pipes, if they're available in that pipe type, like smooth steel pipe. So it's going to generate almost 400 different options for me. 360 options. Some of them it's throwing out because it exceeds that 35-foot standard that low hazard dams are set at. And so it's telling me which ones fit into standards and specifications and which ones we're going to throw out. So that, as you saw, maybe it took about an hour, minute and 17 seconds. So here I have hundreds of results. And again, I can sort those up from smallest to largest or largest to smallest by just clicking here. So I can get a pond anywhere in this site from 6.5 acres to less than an acre. Now, one of the things you're going to want to look at is this drainage area to pond ratio. And that varies from state to state. But like I said, in Iowa, we want something around 15 to 20 to 1. That's a rule of thumb. You know, if you want to keep it full and if you want it to be a nice pond, depending on why you're building it, you might want to get in that category. So if we want to go to 20 to 1, we can select this one. It's 32 foot high at the center fill. It is a maximum pool depth of 26.5 feet. So this is a really deep pond. It's about 3.9 acres. And it's going to cost $47,000. And that's the base price. And again, that's the cost of the earth fill for the actual dam, not the core trench and not the berm, but the actual building of the dam, and then the cost of the pipe. Now, one of the things I can do is if I want to limit these, I can just look at the half. I can click here and it gives me for every half foot of elevation what the least cost is. So it sorts all the different pipe sizes for me. So you can see for a whole lot of these, as we get from, 33 feet up to 30 feet in elevation or in pool depth, the 12-inch is the cheapest pipe. Then it changes at some point in time and it kind of flips around and it can get up to 20 or 22 or 24. But what this really allows me is to go in half-foot increments in pool depths and look at what the best option is for me as far as cost. And so again, if I want to go to this 20 to 1, it's going to give me a settled fill height of about 30.5 feet. It's going to give me a pond size of about 4 acres for this one. Actually is a little cheaper than the other one I looked at because of the pipe size, but this one is at $40,000. Then I'm going to go ahead and I'm going to display that on the screen. And it will again show me the so it's go ahead. I went ahead and it displayed it on the screen here for me. And so you can see the different pool depths on this one. So the dark blue is more than 20 feet. Then the next gradient is 12 to 20 feet. And the next gradient is 8 to 12 feet of water. And then the lightest blue is 0 to 8 feet. And so kind of as you zoom in, you can get a really nice picture of the water depth. And remember, this is with no excavation. It's as if you hauled in all the dirt for the dam. Because again, we really don't calculate excavation of where the contractor is going to take the dirt from, but it will give you an idea of where you're at. So again, once you get to this point, then it's just a matter of clicking on the display on our Create Report. Goes through a process of allowing you a few more checks and balances here, putting in the client's name and your information, and then creating a PDF file. And so in a second, I'll show you the PDF file. And unless new people get on, I probably won't go through that process again. Okay, so Amy said a few new people have joined since the start of it, and so as people join, we'll kind of continue to show the entire process. But remember, it's creating the PDF report for this exact line that's highlighted in blue. So the exact line that is a 12-inch pipe diameter, smooth steel pipe, and that is 3.9 acres in size. I'm going to go ahead and open the report, and I'll show you again what it looks like. The first 2 pages is always repeated, so you can give something to the customer that has some information, but as you get past the first 2 pages, then it's the user's copy of the plan. So basically the cost of the pond, and then the subtotals of where that cost come from. Again, you get a cross-section of the dam. It shows you the berm, the width of the berm, the elevation of the berm, the top width of the dam, the size of the core trench. All that information is provided. Then there is the planning details that for the purpose of record keeping, what was the drainage area, what was the average watershed slope, what was the runoff curve number, all that information, stage storage data that was used and generated, and then the earthwork dimensions. All right, and then runoff curve number information, and lastly, all the technical designs that were used, populated with the information from that specific design. And so it plugs in your drainage area into the equations, the average watershed erosion, the sediment delivery within the emergency, or within the temporary pool and the permanent pool, gives you all the information so you can look through those as an engineer and see how we got to that data. All right, so that's the second one. So we've done 2.5 an hour with the explanation. And so now I'm going to go ahead and I'll move to our third one. And again, if you have any questions of the process, type them in the chat, and then Amy will be happy to help out answer those. If we think that it's a question that we need to answer orally, I will stop and do that. All right, so I have to remember to clear out my old one, even though I zoomed to a new location. I have to clear out my old dam because I can only do one pond at a time on the screen. And then I'm going to look for the location of where I want to be. And I don't find exactly, did I type that right? 30, 30. Okay, we'll find a location here that works. I'm going to turn on my contour lines. All right. And you can see there are a scattering of ponds here already. There's a lot of ponds that have been built in this area, so obviously it's a good location for ponds. And I would do next this pond right in this area, so you can see the drainage area kind of coming up along here. So the first thing I'm going to do is I'm going to locate my dam where I want that to be. And so I'm going to start at the top of one hill. I'm going to go down through the draw, and I'm going to go up on the top of the hill on the other side, so I create an impoundment structure. Then I'm going to click on my draw watershed, and I'm going to hook to the end of my dam, and I'm going to draw in my watershed. Okay. All right, and then I will draw in my flow line of where I think the longest distance that water is flowing. Maybe something like this. And then I'm just going to put in a runoff curve number here of 75. On this one, I'm going to pretend that I know close enough what I'm going to do. Then I'm going to generate my results. So the question while we're waiting?
Yeah, Don Etler was asking, or he said in 2009, the NRCS changed the soil hydrologic classifications for a lot of the prairie pothole region. It increased the calculated runoff by about 40%. Were there similar changes in the more rolling parts of the state where the ponds are often built?
Don, I can't tell you whether the hydrologic groups changed throughout the state, but we have the most updated version of the soil database. And so whatever NRCS has recalculated those hydrologic soil groups from A, B, C, and D, our software reflects those most updated ones. In this case, I'm going to go ahead and I'm going to accept all the default values that are here. So again, I kind of went through some of the top ones before, but in Iowa, NRCS recommends a minimum of 35 years of sediment storage. And so we plug in an average of 5 tons per acre soil loss, 40% delivery rate, 80% is delivered to the permanent pool, 20% is delivered to the temporary pool. But then that's what gives us the minimum pond design, is that much sediment. Now, if you want to override that, you're certainly able to do that. I could put in 0 so that there's no minimum years of sediment storage. Or if I think the erosion is higher or lower, I can change that factor too. We're going to go ahead and accept those. I'm going to leave steel smooth pipe checked here. Again, I can check all these or none of these. And then if I think that my spillway, my auxiliary spillway needs to be wider than 20 feet, I can do that. But I think in this case, a 10-foot wide one will. So this is not a tool that you can use with no professional judgment. And so if you are a person off the street that wants to design a pond, it's unlikely this is software for you, because we are dealing with engineering things. And so there are things that have to be done right. You have to have an understanding of engineering principles in order to do it. So in this case, again, I can look at the watershed and I can say, yeah, I think a 10-foot wide auxiliary spillway would work. If I want to look at options of both the 10 and 20, I can put that down. If I want to go and put other at 15 or 30 or 100-foot wide auxiliary spillway, I have the options of what I want to do. But I'm going to accept the 10-foot bottom, and then we'll go through and we'll generate all the options here. Now all the pipe flows, all the routing, all that information is being done by NRCS standards. We actually have the code for Wind Pond, which is the program that they by and large use for small structures, and that's actually embedded in our software. And so that you can it's using the code. So we ought to get the same answer that Wind Pond does, assuming that we're both using the LiDAR data to calculate it. And so on this site, we have 450 options based on the things that we've added. That's the most we can have, but the program is sorting out some, like if it's over 35 feet of fill height, that gets into a category 2 dam, and we just don't get to that level. And so we're refining the results, giving people within certain parameters all the options that are available here. So again, we have all the options available. We can sort the cost, and the least cost option for a pond here is $14,000. And the largest cost option that we give is $60,000. And that's all based on the height of the dam. So the highest cost option is 11 acres, almost 12 acres of permanent pool. And the lowest cost option is 2.4. So you would expect that, a big swing in pool size, creating a different elevation for your dam, is going to really change that. The other thing that changes is the type of pipe that we have. And so I've limited the options to a half-foot cost here. And again, in Iowa, I want to get something where that's 15 to 20 to 1 ratio. And again, it depends on your objectives. If you don't care whether this pool stays full, like you're using it for irrigation for the year and you're irrigating your crops, you just want to store the most water possible, then you can go ahead and take a much lower drainage to pool ratio. But if you're looking for a recreational pond and you want it to stay full and you want the grass to go right down to the water level, that 20 to 1 is not a bad option. And so we'll pull out an 18 to 1 here. It's got an 8-inch smooth steel pipe. It's about 8.5 acres a pond for $42,000. I don't know for you, but for me, that's a pretty reasonable cost for a really beautiful, nice pond. And so we'll go ahead and display this now on the map and see what it looks like here. or even new people that haven't seen it. So you can now see the water line. I'm going to turn off the contour line so it shows up a little better, but you can see the water levels as it should. Follow the contour lines there. We'll turn off the contour lines. We can zoom in a little tighter, but you can see that, you know, we've got the different pool depths from the dark to the light. I don't think I explained that the red is the temporary pool. So the dark blue is the elevation that water will be when it hits the principal spillway or the pipe. And then, as most people know, the point of a pond is to also take up some of the flood potential. So when it rains really hard and the pipe can't take all the water as it's coming in, the water kind of stacks up behind the dam until it hits the emergency or the auxiliary spillway, then it goes over the top. And that's actually what the red line is that how far the water will back up under conditions where the emergency spillway needs to begin to run. So you can see on this one, we're probably actually, if this is a property line, we're backing water up to that property line and on the neighbors. And so we will either need to get an easement from the neighbor if in fact this is a property line, or we'll have to choose something smaller. And so we could choose something smaller by picking out something that actually is a little smaller, and maybe we're up in this 21:1, which is still pretty darn close to what we want to be. And then we can display it on the map, and we can see if we can actually make a difference in the pool size. Are we bringing that pipe and elevation down enough to get the water off the neighbor's land so it's fully contained on this operator? And so you can continue to, and the other thing you might want to do is put in a bigger pipe so your temporary pool is smaller. And so there are a lot of options here that you can really begin to play with and help a farmer, a landowner understand what their options are for putting it in. And so you can see that I didn't lower it enough to actually get it off the neighbor's land. And so it's very possible that I'm going to have to go to something a lot smaller where my ratio is better. I might have to move it downstream, or it might just show me that this isn't a good site for a pond. And so those are all considerations that you need to do. You shouldn't get into the habit of thinking that every site is a good site for a pond, because it's not. Sometimes no matter what you're going to do, you're going to back water into the neighbors, or you just can't get something that's right. And so this is a good way of checking to see if the site that you have in mind makes sense or not. So with that, I'm going to move on to the next pond. All right. So again, I'm putting in the section, the township, the range, the state, so I can zoom to the location that I want. I always forget to clear out the old pond, so I'm going to clear out the one that I just did so I can do another one. And then I'm going to locate, I think I'll do this time, there's certainly potential right at this site here. You'll notice as you zoom in, there are two different map layers that we use. We use the ESRI one for a certain zooming in, but we can only zoom so far in on that map. What happens is we want to zoom in tighter, then we go to a different map layer at that point in time. So I'm going to turn on my contour lines so I can see where I want to draw my dam. And certainly this is an option. I think that's going to work out fine. So I will draw my dam. Again, I'm going to start at the top of the hill. I'm going to go down through the draw, back to the top of the other hill. I'm going to double click, and that's where my dam will be. And then I'm going to draw in my watershed. And again, I won't be perfect on this, but you get the general idea. Then I will, as I pan up, I don't know if I probably didn't get my whole watershed. So if I want to go and edit that watershed and make it maybe a little more accurate, I can move those vertices. I can go back and save my watershed, and it went from 64 to 68 acres. I can draw my longest flow line again for time of concentration. Yeah. This might run up, actually the longest time might be like right here through that pond. Okay, again, I've done my runoff curve number several times. I'm just going to skip that. And I'm going to say I'm going to use a runoff curve number of maybe 78. I think that would be a good one. And I'll calculate runoff curve number on my next one, but on this one I'll just put in a number. So again, it's going through and it's figuring out what the parameters are for the default values. I'm going to get a list of those default values, and it's up to me whether I want to change those or not. And so as I go through the process, if I want to change any of these default values, I can. I'm going to go ahead and accept those. In this case, maybe I'll put in a PVC pipe instead of a steel smooth pipe. I'm going to stick with my 10-foot wide auxiliary spillway. I'm going to click finish. And now it's going to start calculating the possibilities for me. So again, anybody that has questions, feel free to type those in, and we'll either answer them written. If Amy knows the answer, or she'll read them off and we'll talk to the whole group about them. Or if she doesn't answer your question to your satisfaction, make sure you get back to us, because we want to get your questions answered today. And at the end of this, we'll open up all the mics, see how that goes. But we'll open up all the mics and see if anybody has any questions to ask. So again, it's figuring all the options. It's throwing out the options that don't work, because certainly there are options that don't work. Again, when we look at the permanent pool size, we can look at anything from an acre up to 6 acres, little 6.2 acres. You can look at the costs associated with them. You can see over here we've got pipes. We've got 8, 15, 12, 10, 6-inch, 18-inch pipes. We just have all the pipe sizes that work for this site. I only asked for PVC pipe. We do all straight pipes here. We don't do any with an elbow in it. And then we can do depth of fill. So if you wonder how much depth of fill there is and whether you're crushing that pipe or not, we give the maximum fill depth. But on this one, I'll take a few extra minutes and show you some of the extra things that you can get here. There's all these things checked that you're getting, like settled fill height and settled fill height from back toe. But you can also get the percent of the pool that's less than 6 foot deep. You can get storage to the top of the fill, the volume of the below the auxiliary spillway, volume of permanent pool, volume of temporary pool. You can get the auxiliary spillway storm event and the principal stormway, like all that information here. You can get exactly what it is. And so you can begin to look at these, and you know, if you're building something for irrigation and you want the maximum volume in the permanent pool so you can irrigate out of that, that might be what you want to look at. If you want to look at ponds for flood control, then you're looking at that temporary pool, like how much water can you stack up behind that dam on a temporary basis before it goes over the emergency spillway. And so that really helps you understand whether it's a pond that's really good for flood control or not. And so we tried to give you all these options. If you check one of these options, say I want to view it, it gets put on the end of the list. And so then you can see that. And so we've got it so you can check any of these columns on or off. All right. So let's go to, let's say I want to do irrigation, and I want the maximum pond size here. And if it goes down in the summer because I don't get enough rainfall, that's fine, but I want to fill it up in the spring. So I'm going to look at a pool area of 11:1 here, $63,000, and I'm going to display that on the map. right? So now it's displayed on the map, and I can turn off my contour lines to kind of clean up the image. But again, you get a really good idea of what this pond's going to look like. Most of it is going to be in treed and forested area already, and so you get a pretty good idea of what's going to be flooded out, how far the water's going to back up for this particular scenario. If I want, then I can go ahead and I can generate my report, but I won't generate a report on this one. I click on create report and I can. Another interesting thing that I've not talked about is this export to WinPond. We actually create a file that you can save. So when you click on this, it allows you to save it to your desktop or wherever you want to save it. And then if you open NRCS's WinPond program, you can actually load this session into WinPond. And so then if you want to put WinPond to put in an elbow or any other feature, you can use the data out of our PondBuilder in NRCS's WinPond program, which I think is a really pretty cool feature. And it does work really slick. All right, so assuming that one's good enough, I'm just going to move on to the next one. Amy, are there any questions that need to be answered? Okay. All right, so I'm going to delete this one, and we'll just move to the next one. And so I've done 4 in an hour, so I'm not quite living up to my 6 in an hour, but getting pretty close here. And these are all in different, all these pond designs are all in different locations of the state. Started with Carroll County, went to Guthrie and did one in Union County, and this one is actually Louisa County that we're looking at here. So kind of locate where I'm at. Like I said, I kind of picked some of these out this morning. No, it doesn't look right. Now, I probably should turn on my boundaries. There, so here we go. Here's the one that I was looking at this morning. So I'm going to go ahead and I'm going to turn on my contour lines. Again, these are 2-foot contour lines generated by oh, I typed in the wrong legal description. That's why I didn't get to the right place. There we go. There's the site I'm looking for. All right, so we're going to do a dam across this drainage area here. Again, this is Louisa County, southeast Iowa. We'll draw a pond that starts at the top of this hill. It's going to go down through that draw. It's going to go to the top of the next hill. Then I'm going to draw in my watershed. All right, and so you can see that the watershed's 174 acres. This is a pretty decent sized watershed. I'm going to draw in my longest flow line. Probably going to cross this road through a culvert here, something like that. All right, then I'll do my runoff curve number on this one and actually go through the log method of doing the runoff curve number. All right, I'm going to assign the unassigned ones. I'm going to assume that it's pretty well tiled here. I'm going to assign those C, hydrologic group. I'm going to apply those. I'm going to turn off my contour lines because I don't need those anymore, and we'll clean it up a little bit. Now I'm going to go through and I'm going to do my land use, and I'll start by cutting out my road. All right, and then there's probably some pasture down and through here that's worth cutting out. Oops. Again, I don't want to spend too much time on this, but it's kind of tedious, but you see how you can draw the different polygons for the different land uses. Then I'm going to go through and click on my land uses, and these are the land uses just by NRCS standards. It's copied right out of the engineering field manual. But I'll use straight rows because I can see these are straight, and I'll assume the crop residue is good here. Same thing here. This is pasture, so I'll come back to that. Okay, we'll go down, and then I'll do this is row crop yet here. Then I'll do the pasture, and I'll scroll on down to pasture. And lastly, I need to do the roads, so I'll assume these are gravel roads for today. Just scroll on down to the gravel roads, including right-of-way. So I've got all my land use done. I've done my hydrologic groups. I'm going to click on calculate the runoff curve number, and in a second we'll have our runoff curve number of 82. I'm going to apply that. Now I'm going to go through and we'll start calculating default values as we've done in every other case. So these are the default values. Again, runoff curve number of 82, a watershed slope of a little over 6%. I'm going to use the 3-to-1, 3-to-1 front slope and back slope, and so on down. I'll just accept the values. Instead of a PVC pipe this time, I'm going to use an annular corrugated metal pipe and click on finish. And again, it's going to run through. It's going to give me all of my options. It will give me all the pipe sizes and pipe types that I selected. Well, actually, for the pipe type that I selected, it will give me all the pipe sizes available for that and fit this pond. It will give me the options for a 10-foot auxiliary spillway. And so as we're going through that, you've seen this multiple times, and so this is my 5th pond in an hour, and so the hour is up. I won't do the 6th one, but you can see where it's very quick. If you were just doing this to kind of decide the cost of a pond and help a farmer decide for flood control or irrigation, it's really very, very useful, and you can easily do 6 in an hour if you just crank them out and getting information. And so on this one, we get a range from anywhere from 15,000 at a pool size of 2.7 acres up to a pool size of almost 14 acres of 45,000. And so this one of 14 acres is really nice. It's got a 13-to-1 pool area. We can kind of scroll on down till we get to a 15-to-1, and then we can display it on the map. But while this is pulling up, I think I'm going to just go ahead and open up everybody's mics. So I asked everybody to kind of muffle the background noise in the back or off to start muting people. But if you have any questions, I am more than happy to answer questions that you have. If you want to email questions in afterwards, we can keep the line open for a little while, and you can just go ahead and type your questions in or email them directly to myself or Amy, whatever you'd like to do. And we have to get information. We'll get information back to you. But I'm going to go ahead and unmute everybody. Amy, how do I do that?
They have to do it themselves. You have to do Carl.
Oh, so Amy said everybody has to unmute themselves if you want to ask questions. But everything should be open, and if anybody has any questions, I am happy to answer those for anybody as we go through it, at least to the best of my ability. All right. Well, I appreciate everybody getting on. I hope that this is what you were looking for. If it's not, get a hold of us if there's more detail that you would like. If you want to talk to us about licensing the software, that's great. If you want to just talk to us about a service of how you can, if you're interested in the pond, how you can get this information. One of the things I didn't address is that we can launch our software any place that has LiDAR. So, if you're on the West Coast and you're in Oregon and Washington, if you're in California and LiDAR data exists, we certainly can launch there. Obviously, there's an upfront cost of getting the data and getting it loaded. But in addition to PondBuilder, we also have Basin Builder for water and sediment control basins. We have Wetland Builders for wetlands. And then we have grassed waterways. And so the grassed waterways is a really nice feature, whether you're wanting to do a drainage ditch or a grass waterway for erosion control. Regardless of what it is, the software can handle it and really give you a nice output. The other thing in Waterway Builder, if you just think of it as a ditch builder, if you will, you can get a machine control file. So if dozer operators or excavator operators have machine control on it, you can actually get a file that plugs into their controller, and instead of going out and staking the channel or the ditch or the grass waterway, they can actually just use their machine control to build it. And so there are a lot of options available. The last tool that's not engineering and structural wise is our soil calculator, but our soil calculator calculates erosion on 3 meter by 3 meter pixels, and so it uses the Russell II model, and in 160 acres it runs about 80,000 times. But what's really nice about the soil calculator is it gives the farmer or the landowner an image of where erosion is occurring and how much erosion. And so instead of just running an erosion model one time in a field, we're running it on a raster basis and using the LiDAR data to measure slope length and steepness. But again, we're running full runs of Russell II, I think 80,000 times. We can actually track the sediment delivery and the sediment transport and erosion from the top of the hill all the way down to the stream. And so if you're looking at from a water quality standpoint where the major sediment loads are entering a stream, this tool is very useful in helping you identify whether it's some of these concentrated areas that might be coming down in the grass waterways or water and sediment control basin, or whether a filter strip all the way around your pond, your stream, or anything else is really going to help, or do you need to focus in a few specific areas? And so that soil calculator has a lot of really nice features from a water quality standpoint and from a soil health standpoint.
Someone asked if we're going to do a webinar for soil.
So somebody asked if we're going to do a webinar for soil calculator. We certainly can if there's interest. We can get something scheduled out in the next couple of weeks, maybe 3 weeks out. Any other questions? We've got quite a few people on the line. Right. So again, we've done our best to build the software around NRCS standards and specifications. But you also have the flexibility, just like with NRCS software, you have the flexibility of modifying any of those. So whether you're using wind pond or the grass waterway, there are suggested standards and specs, but the design software allows you to work around some of those too if you have a unique thing. And so we've tried to do the same thing. We've tried to ramp it up so that it's very, very, very fast, very easy to use. and gives really good results. But again, as I started in the beginning, is that nothing is an engineering design until a PE signs off on it, and that needs to be very clear. What we give you is a plan, and what you do with it and how you trust it is up to you. You need to look at the engineering behind it, you need to look at the LiDAR data behind it, and you need to make it your own judgment. But there are a number of private engineers using this as a design and getting information out of it and moving forward with their engineering PE onto it. And so again, give us a call. We'll work out any questions you might have and get you answers, but I appreciate everybody joining us today. Thank you.